Hello again, everybody. Today's topic, radian and degree conversions. So we're going to be converting from radians into degrees and from degrees into radians. If you don't know what a radian is, you got to check out the vocab section of the website, and it will explain to you that a radian is how many radii fit around a circle. Okay, that's what a radian is. So check out the vocab for a visual on that. The conversions that we're going to be using are pretty basic. Okay, they're going to be giving us a degree measure that we want to convert into radians. So they give us a degree measure, an angle measure, right, in degrees. What we're going to do to convert it to radians is we're going to multiply by pi over 180. Super easy to do, nothing to it. One thing I'm going to suggest, just to make your life a little bit easier, is that I would put whatever your degree measure is over 1. Okay, why am I going to do that? Because all I have to do now is multiply going straight across. Okay. Then the final step that we want to make sure we do every time is reduce to lowest terms. Okay. If you have one of the calculators at school, there's a method to doing that. If not, you're going to have to just do a little bit of quick division. Just keep on simplifying the numbers and reducing as much as you can. Okay, so let's look at an example, couple of problems. Now, after watching the first example, you should have enough information to do these on your own, so you can if you'd like to. If not, we're going to do them together anyways. Okay, so this tells us to convert each degree measure into radians, we want to leave our solutions in terms of pi. This part that says leaves solutions in terms of pi, that means we want a pi in our answer. We don't ever want to use that 3.14 stuff anymore. Okay, we want the pi symbol. It's way more accurate, and it's a lot easier to deal with too. Okay, so problem A, we have 90 degrees. We're going to multiply by pi over 180. I'm going to throw a 1 underneath the 90. Again, that makes my life a little bit easier, because now I can multiply straight across. 90 pi over 180. Well, if I notice that I have two zeros, one on top, one on bottom, those reduce because they're both divisible by 10. And now I've got 9 over 18. I should recognize 9 and 18 are both divisible by 9. 9 divided by 9 leaves me with 1. 18 divided by 9 leaves me with 2. So what I have on the top here is 1 times pi, which is just plain old pi. And I've got 2 on bottom. So my final solution of 90 degrees converts into pi over 2. We want to put a little r, little capital R, for radians. Okay, so 90 degrees is equal to pi over 2 radians. That's it. That's as easy as they get. Okay, so again, if you want to try out any of these on your own, go for it. Pause the video and resume whenever you want to check. We're going to multiply again. 18 over 1 times pi over 180. That gives me 18 pi over 180. I should recognize that both of these numbers are divisible by 18. 18 divided by 18 is 1. 180 divided by 18 is 10. So we've got pi over 10 radians. Okay, one more problem to check out. 27, let's put it over 1. Multiply pi over 180. That gives us 27 pi over 180. Alright, both of these numbers look like they're divisible by 9. So 27 divided by 9 is 3. 18 divided by 9 is 20. So what I have now is 3 pi over 20 radians. Okay, pretty simple, pretty easy. All three of these are in terms of pi. They all have the radians because we want them to be in radians. Okay, so I have 3 more problems to do. Again, same steps. So if you want to try these out on your own, go for it. They're pretty easy. You should feel pretty confident about doing these. Okay, so we've got 45 times pi gives us 45 pi over 180. Both of these look like they're divisible. Well, maybe I'm not sure. Maybe I want to divide by 9 because they're definitely both divisible by 9. That gives me 5 over 20. Hey, look at that. 5 and 20 are still divisible, both by 5. So that's going to be 1. And that's going to be 4. That leaves me with pi over 4 radians. Okay, so it's a matter of reducing. And your calculators at school can reduce for you. If not, it's easy enough. You just divide the top and bottom by the same number to reduce them lower and lower. Okay, so we're going to, again, put 54 over 1 times pi over 180. 54 pi over 180. Well, they're definitely both divisible by 2. So let's see. 54 divided by 2, that gives me 27 and 90. See, these are a lot more easy numbers to work with, right? 27 and 90 are both divisible by 9. So 27 divided by 9 is 3. 90 divided by 9 is 10. So I've got 3 pi over 10 radians. Last problem of this set. 72 over 1 times pi over 180. That gives me 72 pi over 180. These numbers are both divisible by 9, right? 72 divided by 9 is 8. 180 divided by 9 is 20. Oh, and these are both divisible by, it looks like, 4. 8 divided by 4 is 2. 20 divided by 4 is 5. So I've got 2 pi over 5 radians. Okay, so that was degrees into radians. We can also go back the other direction. We can go from radians to degrees. So here's your conversion formula, right? We want to take the angle they gave us in radians, and we're going to multiply. This time, we're multiplying by 180 over pi. Now, you might notice I started drawing a line here. Sometimes we can put a 1 underneath if our problems are whole numbers like you see here. That's fine. We put the measure over 1 and multiply by 180. But other times, we're going to have a fraction already given to us. So we don't want to put a over 1 here, right? We want to just use the fraction that they gave us, and we'll multiply straight across. So when we look at these problems, it really depends on if it's a whole number or a fraction, whether or not we put it over 1 or not. Okay? Also, remember, we're changing these into degrees, so our final solution has to have a degree symbol in it. All right, so here we go. What they gave us here, 2 pi over 3 radians. So I've got 2 pi over 3. My formula says we need to multiply by 180 over pi. Quick side note, we're going from radians to degrees. Now, radians generally have pi involved. So the way I remember which formula to use is that if I'm given a radian, which has a pi normally, I need to divide by pi in order to get rid of it. That's how I remember to use 180 over pi for these problems. Because what you notice here is that when I multiply by pi on top and pi on bottom, the pi's cancel out. And I've got 2 times 180, which is 360 divided by 3. 360 divided by 3 is going to be 120 degrees. Okay? Pretty easy to do, easy to work with. Check out these other problems. You can do them on your own, or you can do them with me. Here we go. 2 pi over 5 times 180 over pi. Again, my pi's cancel. 2 times 180 is 360 divided by 5. Let's see, 72 degrees, that looks like. 360 divided by 5. Again, you can use your calculator for that final step if you're not good at the division in your head. Completely up to you what you want to do. Okay, this last problem on this top line here is where we would want to put our number over 1 because they don't give us the fraction that we were looking for. So 3.7 over 1 times 180 over pi. Now you notice that our pi's, there's no pi to cancel out on the top and on the bottom. So we're going to still do this problem like normal. We're going to do 3.7 times 180. That's going to give us 666 on top. 1 times pi is going to give us pi on bottom. So if we divide 666 by pi, which let me check on my calculator. Google calculator works pretty well. We want 666 divided by pi, and they tell us that number is 211.99. And this problem says round to the nearest tenth. So this 9, tell this 9 to jump up to a 10. So that becomes a 10. I have to carry my 1. That gives me a total of 212 degrees. Okay? So there are 3 more problems that you can try out. See how you do with them, and check them out when you're ready to. We're going to do 4 pi over 9 times 180 over pi. Pi's cancel. We've got 180 times 4. That's 720 divided by 9. That gives us 80 degrees. Problem E. 7 pi over 10 times 180 over pi. My pi's cancel out. 7 times 180 is going to give me 1,260 divided by 10. That's going to be 126 degrees. And the last problem, we have negative 16.8. Let's put that over 1 times 180 over pi. Well, let's see. We want to do 16.8 times 180. That's 3,024 divided by pi. Okay, so that gives us 962.56. That 6 tells that 0.5 to round up, so 962.6 degrees. That is it for converting radians into degrees. Pretty easy to do. Just do what you can to remember which formula goes with which one. If you're going from degrees to radians, you're doing pi over 180. That'll give you the pi symbol that you want. If you're going from radians to degrees, you do 180 over pi. That should hopefully cancel out any pi's that are remaining. And your formulas from there, it's just a quick either calculator or mental math. Okay? Any questions you have, leave them on the website, bring them into class, and we'll do what we can to answer them for you. See you soon.